Okay, to start things off, this is we're going through practice test, freeform practice test. Start things off. Here is all the answers real quick. Then we'll go through how to solve each one. B, A, D on the first page, followed by D, B, C on the second page. Then A, C, 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 A on page 4. Finally, to finish things off, D, C, D, A. Now to start again at the beginning. Okay, folks, let's look through this other practice test. Okay. Starting here, magnetite oxidizes to hematite, iron 3 oxide, via the following reaction. For magnetite plus oxygen goes to 6 hematite. If the rate of hematite production is 2.5 per day, what is the rate of magnetite consumption? So I can simply put that rate 2.5 over 6 is equal to rate of over 4. So cross multiply, you get that at 2.5 times 4 over 6 is, it's going to be 1.67 consumption per day, or B. Tin 126 is one of the most more radioactive among the byproducts of nuclear reactors at the half-life of 230,000 years. How much of a 1,000-gram sample will decay in the average human lifetime of 71 years? So we have A sub 0 is defined as 1,000 grams. We have T1/2 is 230,000. And we have T as 71. Since they're both years, that's fine. You don't have to do anything else there. So ln 2 over 23, 230,000 gives us our K of a small number. Let's see, it is, something like 0.00003014. That's our K. So plugging that in. ln A sub T for 1,000 is equal to negative our K times 71. Times 71, make it negative. Do the inverse log of that answer, times 1,000. And you get, how much is left? 9,999.8. However, that is amount, that's A sub T. This problem was a little bit trickier. How much will decay? Decay. So how much is lost? Well, I subtract that from 1,000. I get 2.14 gram, 0.214 grams will have decayed. That one is only really tricky because of the wording there. It's a little bit harder on that particular problem. Okay, here's one where you actually have to determine the orders before you determine the rate. So when I compare 1 to 2, what happens to our B? So we have, so 5, 7, 57.2 times 10 to the negative 4th over 3.58 times 10 to the negative 4th equals 0.2 over 0.05 to the n. I'm simplifying a lot of steps here. I turned this guy into the same units because it's 5.72 times 10 to the negative third. So 57.2 divided by 3.58 makes that. It's gone up by a factor of about 16. 0.2 divided by 0.05 goes up by a factor of 4. How can these be equal? That can be equal if n equals 2. N equals 2. Well, let's look at experiment 1 and experiment 3. Experiment 1, so we have 8.94 times 10 to the negative fourth over 3.58 times 10 to the negative fourth equals 0.25 over 0.1 times to the nth. 8.94 divided by 3.58 is 2.5. Well, 0.25 divided by 0.1 is 2.5. That only works when m is equal to 1. M is equal to 1. So our generic rate law without the k is rate is equal to k a to the first, b to the second. With that in mind, I'm going to plug in our values and solve for k. You may want to double check it with 2 experiments. If that works, 2 experiments you should get the same k. So 3.58 times 10 root negative 4 divided by 0.1 divided by 0.05 squared gives you 1.432. I'm looking like D, but I'm going to double check. I'm going to double check by using experiment 2. So 5.72 times 10 root negative 3 divided by 0.1 divided by 0.2 squared, 1.43. So seems to work. That is plus 1. Right here, that page 1. Reaction diagram, pretty simple stuff, as long as you know how to read it. Activation energy is the energy. That right here is the activation energy. The difference between here and here is my delta H. So the difference between the starting and ending point is my delta H. The difference between the starting point and the highest point is my activation energy. So I need an activation energy of positive 15 and an enthalpy of negative 10. So meaning negative 10 means exothermic, means it's lower than starting. So because of that, these are definitely out because those start higher. That's definitely out because that's actually inverted. So -7 minus -22. The difference between those two numbers is positive 15. So this 15 activation energy, perfect. The difference between -22 and -32, -32 minus -22 is -10. -10. So correct answer is D. Don't be thrown off by this. This is incredibly easy if you know what you're reading. This is where you have the transition state up here. There's your reactants. There's your products. A second order reaction took 50 minutes to decrease from 15 grams to 0.52 grams. What would be the half-life of the initial 15 grams? So we got A sub t is b 0.52. A sub 0 is b 15 grams. We're saying t is 50 minutes. So 1 over 0.52 equals k times 50 plus 1 over 15. Step 1 is to solve for my k. 1 over 0.52 minus 1 over 15. And then divide by 50. My k ends up being something like 0.0371. And our half-life for a second order is 1 over k a sub 0. So 1 over 0.0371 times 15 equals our t1 half. 15, and then invert that. You get 1.79 minutes, or rounds up to 1.8 minutes. So it took 50 minutes to go from 15 to 0.52. But so from going to 15 to 7.5 took 1.8 minutes. Really, really slowed down there. Okay, what is the order of C following reaction as a rate law of blah, blah, blah? Well, really, you could actually just look at this. It's very complicated, but if I compare experiment 1 and 4, C doubles. The concentration of C doubles. Here it goes from what halves really, 3.2 to 1.6 to the factor of P. And that goes from 3.3792 over 8.448. So we don't even really need to look at the other things. 0.792 divided by 8.448. So that's 2p equals 4. So it must be C. But if you did this, you would find out that when I change A is first order, B is 0 order, and C is second order. And the units on this kind of represent that. But we don't need to do that. That's far more intense than we need. Another first order equation. Radon gas has a half-life of 3.8 days. Leaks into your basement. 150 psi. How long before it's gone down to 15 psi? So I have A sub t is 15. A sub 0 is 150. And T1 half is 3.8. So ln 2 over 3.8 gives us our K. Okay, doing that real quick. K is something like 0.182. And you're saying ln 15 over 150 equals negative 0.182 T. So see, ln of 15 over 150 as negative 2.3 divided by a negative 0.182. You get a T, it takes 12.6 days. 12.6 days, so it takes a little while. Not super long, but it takes a while. At 0 degrees, a certain reaction has a rate constant of 7.4 times 10 to the negative seconds. And at 75, it has 9.2. What is the activation energy? So this is Arrhenius. So 273 Kelvin. And at 75, that is 348 Kelvin. So equation is ln K1 over K2 equals EA over R 1 over T2 minus 1 over T1. If I plug this in, our values are okay, 7.4 times 10 root negative 2 divided by 9.2 times 8.314 divided by my 1 over 8 minus 1 over 270. Okay, so with that in mind, I get something like 50,792, which you divide by 1,000, it gets it to C. Okay, what is the correct K expression? What's the correct K expression? So remember, solids do not count. Nothing else would. Products over reactants raise the power coefficient. So zinc chloride, good. H2, good. HCl squared, good. It is C. Products over reactants. So not these because those are reactants over products. And not this one because it has zinc in it. Which way would the following reaction shift? In this reaction, if acetic acid is 0.8 and these are, so our Q expression, Q equals products over reactants. So Q equals 0.8 over 4.5 times 10 to the negative third and 3.2 times 10 to the negative third. So 4.5 and 3.2, 10 root negative 6 divided by 0.8. So I get 1.8 times 10 to the 1, 2, 3, 4, negative fifth. They happen to be, that happens to equal to K, so it's actually at equilibrium. Wow, congrats. For once it's at equilibrium. What relationship do KP and KC share with this reaction? So, reaction KP equals KC times RT to the delta N. So there's 1 mole, there's 3 moles of gas on the right, and there's 1 mole of gas on the left. In delta N becomes 2. 3 minus 1 is 2. So it's A again. If that was water liquid, if that was water gas, then we could say it's B. But because it is water liquid, don't include it. Last page real quick. For the previous equation, blah, 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 if this is exothermic, well, sorry, not exothermic, if this is endothermic, all of the following would increase the amount of methane produced, except you increase the temperature, you're adding a reactant, so it makes more product. Removing oxygen, you remove a product, it's going to shift it to the right. Adding more CO2, you're adding a reactant, it should shift to the right. Increasing pressure. So there's 3 moles of gas on the right, 1 mole of gas on the left. So when you add pressure, it shifts to less gas. So that is the correct one for D, D for 12. Mixing. Oh, this one is a pain. Much harder than anything we will see because the volumes change. The volumes will change. But this was used based on one we used to do, a lab we used to do. So you have to divide the M1V1 equals M2V2. So the iron thiocyanate is 2.5 times 10 to the negative third. You multiply by 5, divide by 10, because we're adding two together. So you get 1.25 times 10 to the negative third, and you get 1.25 times 10 to the negative third. And that's 0. That's minus x plus x. 1.25 10 to the negative third minus x. Well, if that's x, you get, say, 1.05, or 1.046 times 10 to the negative third, because that's also, you also get the same for that one. So your K expression is products over reactants. So 204 times 10 to the negative fourth divided by 1.046 times 10 to the negative third squared, because the iron and the thiocyanate end up being the same. Gives you one. Gives you 186. Well, okay, 180. Yeah. 186. I'm just double checking something. Let's see if I did. If I rounded this instead, using 1046 and used 105, yeah, 20. Yeah, it's close enough to 181. Equilibrium. Let's see. Oh, that's why. Shoot. Yeah, yeah, that's my problem. I used 204 instead of 2. So yeah, it's 181. Typed it in wrong. 181. Yep. 105. 105. So 105. So I read that as 204 with my eyesight. Say it'll be, but it's 181. I got close enough. 181. Which statement about equilibrium is false? The only way to change equal K is by increasing temperature. So that's true. We do not include pure liquids in equilibrium expressions. That's true. The constant K does not have units, despite the units in the compounds of the K expression. That's true. Adding a catalyst will increase the yield by lowering the activation energy. That is false. You do not get more yield with a catalyst. You just get things faster. And finally, 15. If after bubbling chlorine gas through bromine at 500 mils of Br2 exists with 2.5 mils of atmospheres of chlorine and 1.89 atmospheres of BrCl, what would the Kp be? Kp is going to be Br Cl squared over Cl2 because we cannot include the bromine liquid. So it just becomes 1.89 squared over 2.5. 0.89 squared over 2.5. 1.89 squared over 2.5. K is 1.43.